Ta-da. Okay, so last time we kind of took the high view looking at some of the thoughts and things we had to deal with, wrestle with, whatever you want to call it, about voice switching. We'll come back to the idea of identity. We're actually going to park that whole idea of following the identity versus following a number until we get a good handle on how the numbers work. Actually, our first set of lab work, which will start a week from today, we'll bring that back in. For the moment, we're going to get a little more facility with how the numbering plan works. Worldwide, depending on where you're standing and depending on where you're calling, you could dial as many as 17 digits to make a phone call. If you are standing in North America, meaning Canada, Mexico, United States, Caribbean islands, little bit of Central America, you're going to dial 10 digits for a number or 11 digits if it's long distance. Okay, and we're going to look at why that is. The dial plan in North America is very cleverly named the North American Numbering Plan. Clever engineers come up with those snappy names. It actually, believe it or not, is the oldest dial plan. It was developed by the Bell system here. Our phone system in this country in the late 30s and 40s was ahead of pretty much everybody else in the world in terms of automatic switching technology, which is what this grew out of. Later on, what happened is they took this and added on to it to create the worldwide plan we follow, and this is simply a sub-part of that. The ideas work the same across all the dial plans. The way the numbers are used, the way the number space is used changes. In Europe, where you have a lot of towns, a lot of phone exchanges, a lot more than we do actually, a lot of countries and all of that, you have several two-digit subdivisions instead of three like we have for area codes. It's just to facilitate having that many countries and that many exchanges and everything in. So you'll see things like city code and all of that. I'm going to stick with North American Numbering Plan for this class. Like I said, the rules work the same way. You do the same things. You're just grouping numbers differently. Okay? It will take you about 10 minutes to convert to being in a country that does a different dialing pattern once you know the rules. It's just not a big deal. Okay. Now, the NANP came out of the Bell system. And what was going on, we've talked about how exchanges have worked. Of course, early on, exchanges were manual exchanges. You had a person who was literally picking up plugs and plugging them into holes to connect lines. Later, we got electromechanical switching, which first let an operator control the switch remotely by entering numbers on the dial pad. Later on, we let customers, the subscribers, control that system. What you're doing, of course, is entering addressing information, and the switch was programmed. I'm using that term a little loosely, but it applies. Programmed so that that number string set up a path through that switch. These were literally mechanical switches being set, and these things were loud. You'd have to raise your voice to carry on a conversation if you were in the same room with one of these things. I remember going as a Cub Scout down to the one here down on the corner of 7th and Olive Street. When I say programmed, one of the big changes that happened in our world, in our industry, happened in the 50s when we started using computers to control that switching process. Before that, it was strictly manually. And while switches were programmed, the program was wired in. I mean, you literally programmed a switch by pulling out wire cutters, a roll of wire, and a soldering iron. And you built in the signal paths. In the 50s, instead of doing all the wiring that way, we wired the switch generically and then controlled the switch points with the computer. Later on, we changed the switch points to where they were actually moving data, and now basically what you're doing is moving coded audio across a data bus port to port. We'll go there in a minute. For what we're talking about here, we're talking about how to control that process. In other words, how do we address our path through this network? Okay, and that's what the numbering plan is. We'll look a little more at how it works, but I want you to understand the structure and some of the problems with numbering plans. This is the official one we follow. It's the one you'll live and work with if you work in North America. What will it look like in 5 years or 10 years? That's a really good question. We'll talk about the expansion of it towards the end of this presentation. So going back, this is about 1946, just after World War II. We had developed a pretty sophisticated switching technology. To do that, remember this is all circuit switch, so we're building a path from end to end. Telephone systems at the time, exchanges, particularly in rural areas like ours, were manual exchanges. I've already talked about Clotilde Tucker. That was the case in Murray into the mid-60s. There were the last manual exchange in Kentucky, I think, went away in 78, something like that. So, yeah, not terribly long ago. When you have a person running that process, you can do things that you can't do with a computer. I can pick up and say, "Hi, Clotilde, I need to talk to Holland Heart Drugs," and she'll connect you. I don't have to transfer a phone number. In fact, I'll pass this around, kind of put this in perspective. This is a Murray, Kentucky phone book from the year before I was born, 1958. And it's kind of fun. It's cool. You look through. A couple things you'll notice. There are 4-digit numbers in there. There are 3-digit numbers in there. There are 2-digit telephone numbers in there. And there are single-digit phone numbers in there. Remember, you're talking to a person. So a phone number does identify an endpoint, but I can just tell the person, I need to speak to number 1 or number 2. Or what have you. That works. What's one of the ads on? Let me grab one of the ads. Max Churchill Funeral Home, telephone 98. If I'm talking to a person and I say, I need number 98, actually I probably would say Churchill Funeral Home, but if I said number 98, that's no problem. We pull out the plug, plug it in, jack number 98, and we're done. A computer can't do that. Particularly the computers of the 50s, or hardwired logic, like I talked about, where we actually physically wired the computer to put the program into it. It can't do that variable number of digits easily. And so what we had to do was normalize, that was the term they used, normalize dialing to where all extensions you wanted to dial had the same number of digits. That's why we have 3 digits, 3 digits, 4 digits. Yeah. Have you ever played the game of giving somebody your phone number but not matching that pattern? 270-753, 3011. Give it to them 2707-623011 and see if they can remember it. No, you can't, because we've been conditioned to do 3 digits, 3 digits, 4 digits. And that alone is why it's really, really, really tough to get rid of the phone number patterns, even though we really don't need them for an awful lot of telephone anymore. If you're talking about a voice over IP system, you do not need to use numbers at all, period, end of story. Nothing else. Everybody does. Why? Because we're all used to it. And that's why it's here. To get back to why we have this, since we're doing automatic switching, and the computers couldn't deal with the variable number of digits, we adopted this plan. And what they did was look at the population areas of the country. Where are these people, where are the people, and where is our growth going to be in a telephone number, in the telephone area. So they looked around and they decided that we needed to make big areas 3 digits. That's what we recognize as an area code. Now I'm showing a new area code up here. Originally, the North American numbering plan took the form of where the area code was only N01X. Interpret this. Let me write it in the syntax you've seen. N01X. What is N? Any single digit 2 through 9. What's bracket 0, 1 bracket? 0 or 1. What's X? A single digit, 0, 0, hand writes 9, 0 through 9. So if you go through the math on that, this first digit place could be 2, 3, 4, 5, 6, 7, 8, or 9. The middle digit could be 0 or 1, and the last one could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Why did we put this limitation in here? Remember that hardwired programming? We've got 2 groups of 3. How does the switch know if that the first 3 digits I give it are an area code or an exchange code?
We got dial 1 first to make it.
Didn't have to. You're right, that comes into play later, but just given a 3-digit grouping, how would the switch know whether it's an area code or an exchange code? That hardwired logic is very, very slow, and if you're going to make it interpret something fairly ambiguous like that, you're going to have to put an awful lot of circuitry in. Remember, these are physical switches. They cost a whale of a lot of money. The switch element had, let me do the math, 840 contacts. That was one switch. You needed a minimum of 5 of them to make a call, and every group of about 10 to 20 subscribers needed at least 1. It got expensive in a hurry. So instead of doing that, what they did was say, okay, if we only assign area codes, those first 3 digits, with a middle digit of 0 or 1, that logic we can wire in. We can remember 1 digit. I can store this first digit, have the switch look at the second digit, decide if it's an area code or an exchange, and then route it appropriately. What did that mean? Local switches did local calls. They might have to go to in a large city, you might have multiple exchanges, and it would have to send to another exchange based on what the first 3 digits were. If it's long distance, you're going to put an area code in front of it, and remember that hierarchical diagram? If it's a long distance call, and I'm a local switch in those days, I'm just going to, as fast as I can possibly get rid of that call, I'm going to hand it to that switch that's next up the line. So what happened is the switches would remember that first digit, look at the second digit. If it was a 0 or a 1, it sent the first digit and the second digit and everything else that followed up the line to another switch. It was somebody else's problem. They went to their default gateway, to use IP terminology. If the switch remembered that first digit and the second digit was anything other than 0 or 9, it kept it locally and made a routing decision because that was an exchange code. Okay? So it was to provide a shortcut for the pretty unimpressive logic of the day. That's not fair. These, you know, given what they were working with, they made amazing stuff. It's just the economics pushed it towards making this kind of decision instead of building a box that could route all 3 digits. Okay? If you look at the numbers, the first digit can have 8 unique states. 2, 3, 4, 5, 6, 7, 8, or 9. Okay? The middle digit can have 2 unique states, 0 or 1. Just happens to look like a binary thing. The last one could have 10 possible combinations. If you go through the math on that, 8 times 2 is 16 times 10 is 160 area codes. This is 1946. You know, they're less than 200 million people in the country. Great. That's fine. We've got 160 area codes. Gosh, we've only got 43 states. You know, I'm the same age as Alaska and Hawaii, thank you very much. So it made sense in those days, okay? Keep that in mind. Second 3 digits, the exchange code. This was how you selected which local area. Remember, we're putting these exchanges in the middle of population groups. Typically, a town, place like Paducah with Roanoke close by would probably have 1 for each. You know, Louisville was big enough; it had at least 3. New York had dozens. Okay, we numbered them individually. Okay, so remember what's happening inside each area code. Whatever the unique combination of digits is, we have all of the possible combinations for exchange codes. Now, in the old form of this, the exchange code took the form of NNX. 2 through 9. 2 through 9, that's the complement of this, if you'll remember. This is so we can determine this is an area code and this is an exchange code. And then 0 through 9. Okay? So in each area code, we could have 640 exchanges. Cool. How many digits can you specify? How many unique combinations of the last 4 digits can you specify? What's X? 0 through 9. How many unique combinations, how many unique numbers is that? 10. And we've got 10 4 times. So that's 10,000. So when these 4 digits allow me to address 10,000 unique phones. And there's a particular reason that number was chosen. Remember magic numbers? Okay. How far could you push an analog telephone line without doing big time tricks? Pardon? 18,000 feet. Now, think New York. Think 10,000 people. And think how big a radius that is. 18,000 feet will cover it comfortably. You're talking about an exchange roughly every 15 to 20,000 feet. Okay? That's how this was done. And that's why that's 4 digits instead of 3 or 5. With 3, you'd have to put in too many exchanges. You could reach them with wire, but you wouldn't have the number space. With 5, you could end up with people in your dialing area that were too far to reach with the technology of the day. If we were doing it today, we'd do it differently because the technology has different limits. Oh, gee, we'd probably use, I don't know, 128-bit binary address, something like, IP6, which is what ultimately will happen. So let's take a look at how all this adds up. In this time, we've got 160 area codes. We've got 640 exchange codes in each of those area codes. And in each of those exchanges, we have 10,000 numbers. That means we've got 6.4 million distinct numbers in each area code. If you go a little deeper into the math, you end up with about a little over 1 billion unique phone numbers for this whole number pattern. 1,024,000 if memory serves. Sounds great. I mean, this is 1946. I mean, today, there are fewer than 470 million people in North America. We've got over 1 billion phone numbers? No problem. Sure, we don't ever run out of IP space either. What happened, of course, is we had an explosion. The assumptions of the day were that, actually let me go up so that won't distract you. The assumptions of the day made perfect sense with what they were doing. At this time, about half of the households had a phone, a private phone. Now, they expected that to grow. And in fact, they planned on it growing to where every household had a phone. One household, one phone, which needs a number. Businesses mostly had 1, 2, 3 lines. Big businesses had more than that, but most businesses had, 2, 3 lines, not that big a deal. They expected it to grow. Big business might have, a few thousand lines, and smaller ones would have maybe 5 or 10. Now start thinking what happened through the 60s. You got more and more people. Everybody got a phone. By the 60s, phone penetration in terms of lines was about 90%. Okay? Businesses were going pretty much along the way they predicted. Get to the late 60s and a couple of things happened. First off, we had the Carter phone decision, so now it's legal for you to attach your own equipment to the network, and companies started doing just that. Instead of getting their phone service from the Bell system, now there were exceptions to it before this, but it was generally available after the Carter phone decision. Instead of getting your phone service strictly from the phone company, I could buy a telephone switch, link it to the telephone network with a trunk, lease a block of phone numbers, and I can have a pretty sophisticated phone system. You have a sophisticated tool, and it works, and it makes you more money. What do you do with it? You do more of that. So we started using more and more numbers. Okay, late 60s, another little development came along called the Internet. It didn't actually directly affect this yet. Notice I said yet. But we got the idea of where you started having computer-based services that people wanted for information. First off, it was researchers and university types and stuff like that. Late 70s and early 80s, you started seeing things called bulletin boards crop up. Okay. Early day Internet. These are places where I could take my telephone modem. I could connect my Atari 8080 computer, Altair 8080, sorry, I'm slipping. And I could dial it, and I could go on a text-based internet and do email. BitNet was one of the ones I used. Okay, notice what I used to get there. I used a telephone. Okay? If I'm doing a lot of that, my teenage son is probably going to say, I want to use the phone while I'm doing BitNet. Okay, I'll put in another phone line. Now I've got, remember, one household, one phone number. Now I've got 2 phone numbers. Fax machines. Early day email. Fax machine took its own phone line. You started getting this pattern going in even fairly modest households in terms of computers. You started seeing pretty commonly at least 2 lines. So now we've just doubled what the model showed. Businesses are using a lot more of this. The short version of it is we outgrew the projected growth. Now, it took us 40 years to get there. But we started running out of numbers at that point. That's the first, oh my, we're running out of address space world. Short version is, by the 90s, we well and truly were in trouble. Part of it is how we were assigning numbers. We typically were assigning, I'm saying we like I did it personally. Typically, they were assigning numbers in blocks of an exchange. Here are 10,000 numbers. I know you're probably only going to use 160 of them, but it's okay. We've got a lot of them. This is how we got in trouble with IP4. You have 6 computers? Great. Here's a Class C. All 256 addresses. There are plenty of IP4 addresses. We just assigned them ridiculously, and the system didn't really allow for flexibility. But it's basically the same thing going on here. It came to a real critical point in 93, and it took a couple of years to get the fix in place. And in 1995, they made 2 changes to this numbering plan. We kept the same pattern. It's still 3 digits, 3 digits, 4 digits, because there actually is a lot of address space in there. First off, we did the smart thing. We stopped assigning 10,000 number blocks. We started assigning them 1,000 or 100 numbers. Now you can get them in blocks of 10 pretty easily. Until fairly recently, 100 was about the smallest you could do. First change they made was to change the exchange code. Okay, we went from NNX to NXX. Big deal. 2 digits. Look at the math. If I do that, then that adds 160 exchanges to every area code. That's a lot of address space. Okay. With that change, 160 new area codes, and you've got 128,000 exchanges added to this system. Remember that each exchange is 10,000 numbers. So that's a big change. Number one, that happened in January. In December of that same year, we changed the area code from N01 to what we have now, which is NXX. Why? Well, the reason for this 01 has gone away. We started using computers to interpret this in the 50s. By the 70s, we were doing a lot of that. By the 80s, I mean, it just wasn't a big deal. And so the whole reason for that limitation had gone away. So we just said, okay, now we're going to allow area codes with 0 and 1. Both of these changes, you have to realize, though, are not just paper changes. Think what this did to that mom and pop phone company or an awful lot of the co-ops that used older equipment that was either stored program control, computer running a mechanical switch, but those mechanical switches can't change the way the mechanical switches work. You can change the programming on the computer, but the programming can only do what that physical switch is capable of doing. And it was not capable of routing area codes that didn't have 0 or 1 as the middle digit. It wasn't capable of routing exchange codes that had 0 or 1 in the middle digit. Okay? So we just obsoleted an awful lot of people's expensive hardware. This was a huge deal. It's part of the reason it took 2 years to get it pushed through. Yes, sir?
I guess now the computer just knows what the area code is, so when it sees those digits in there, those are not exchanged.
Yeah. In fact, that's what I'm building up to is how we do it now, is we essentially provide a set of rules as to how the computer is to break down a number string, and we actually tell it what that number string is going to be. Okay, hold on, we'll get there. You're exactly right. So, with this change, here's what happened. The original plan, we had 1,024 million DN. DN is directory number. In other words, a unique telephone number across that 10-digit space. 1,024 million DNs. After we made the change to the exchange code, we had 1,280 million DNs. Okay? Look what happens when we I'm sorry?
You said DN is directory number?
Directory number. It's a unique combination of those 10 digits. Okay? After the second change, look what we ended up with. 6.4 billion directory numbers. Okay, this is 1995. There aren't that many people in the world. Now there are. Then there weren't. So we're in good shape, right? Wrong. You knew that was coming. Depending on who you talk to, we've already long ago run out of phone numbers, which is true from a certain point of view. We are going to run out imminently, which is true if you're standing in our area. Well, actually, we're in good shape now. 2 years ago, it was true in our area. Or we've got plenty, which is also true, depending on where you're standing. Problem is, overall, this system is stressed. Doesn't have enough digits. 5 years ago when I taught this class, my prediction was, and you know how predictions about technology are. You ever read one of the House of the Future things from 30 years ago? I'm still waiting for my hover car or my helicopter in the garage, you know. 5 years ago, I was saying you're probably going to see 12-digit phone numbers, mandatory. And you are, sort of. It's just, it's not going to be a phone number. We're going to be using IP6 for this, would be my prediction. IP6 has enough, is the first address scheme we've had in wide use that has ample space. You know, you've all heard the numbers. You know, what is it, 16 quadrillion addresses for every square meter on the face of the earth, or you know, some ridiculous number like that. I'm not real worried about running out of address space in that one. You're going to see some form of this being IP6. We'll come back in 10 years and we'll see what happened. Bottom line, this is still a problem. This is one of those things that even though we're moving away from it, you're still going to have to deal with. Right now, our area is dealing with it. That's why we're having this exercise with our exchange. Now, when we're expanding the amount of address space in a particular area, there are two ways we can do it. We can do what's called a split, and this is historically what's happened. You know, we take a telephone area. Whoops, that's actually not supposed to be there yet. I didn't get it fading in. That's the last thing you're supposed to see. In 1946, when they started all this, Kentucky had one area code, 502. Area codes were assigned by population. Now, anybody in here not used a dial phone at least once in their life? I'm going to feel real old here in a minute, I'm afraid. I feel real old. The kind of phone that you stick your finger in and run it around and go. Yeah, your grandparents have them. I've still got one in the basement because I had one when I lived out in the county a long time ago. The way those phones worked. Yeah. The way those phones worked. Remember that loop signaling we talked about? I close the loop and I draw current. The way the original automatic signaling system worked before touch tone. The way that worked is you would open and close the line to signal a digit. If you needed to signal 1, you open the line once. So click 1. If you need to signal 2, you did it twice. Click, click. And that's what that rotary phone did. If you pulled 2 all the way around and let go, it went click, click, and the switch saw 2 and made corresponding switching movements. It took us 10 times as long to dial a 0 as it did to dial a 1. Because each one of those each time you went up, you incremented by 1/10 of a second. So 1 took 1/10 of a second. 10, or 0, sorry, took 10/10 of a second, or 1 second full. So if I'm assigning area codes, and I want these switches to route as many calls as possible in a given amount of time, I'm going to be real careful which area codes I put where. Remember the difference in the area code? 1 or 0. What's the difference in the time it takes to dial that? 9/10 of a second. Big metropolitan areas got 1 as the middle digit and very low digits on either side. There's a reason New York is 2, 1, 2. More calls are going to route to New York, probably, than are going to route to Murray. Just a guess. Rural areas got higher numbers on the outside and 0 in the middle because not as many calls went to that. We could afford to take the time to route them. Okay? Kentucky, yeah, somewhere in the middle. We got 502. We can be proud. West Tennessee got 901. So in 1947, the entire state was one area code 502. When we got to 1955, population had grown to the point where we were beginning to run out of address space in there. And so they did a split. Basically, I-65 wasn't there at the time, but basically, if you think about where I-65 is, everything east of I-65 was reassigned area code 606. You know, it's Lexington, Louisville. They can take more time, so we'll give them a longer number. Anybody in here from Lexington? Anybody in here a big UK fan? Oh, good. I can have fun. Everything west of I-65 kept the 502 area code. Think about the effect. Now, that one was done roughly cutting the state in half in terms of area. Okay? So I took all of the address space that I was used for a whole state, and I put it in about half of the geography. And then I put another area code on the remaining half. That's what a split does. And that's been the common way to do it. Notice that when I do that, local calls still, in both areas, still dial 7 digits, right? Because in a local call, I know what the area code is. I don't have to specify it. So I only specify exchange code and 4 digits. Local call. Your parents and your grandparents have it hardwired in that 10 digits is a long-distance call, and I'm going to pay extra money for it. How many of you pay for long distance? I know very few people that actually pay for long distance, but it's wired in. Okay. If I were over here, I still dial 7 digits, right? Because it's a different area code. Now, one of the problems was, if my number was 7, when the whole state was a number, if my number was 753-5555, now there are 2 753-5555s, one in this area code and one in that area code, but that's really not that big a deal. Okay? I have a lot more problem because my home phone's 1 digit off of McDonald's. That's a problem. Okay? I get their calls all the time. I'm not coming in today. I finally just started saying, good. Tired of it. Look at the phone number. Okay, 1955. That actually held us for a long time. In 1999, the 502 area code was beginning to run out. And mostly it's because Louisville had grown hugely. The whole area around Louisville, the Golden Triangle, you know, Cincinnati, Louisville, Lexington, had most of the state's growth in that 30 years, 35 years actually. So they split 502 again, but look what they did to it this time. They did it by population instead of geography. This is 502. Remember, this used to be the entire state. This was reassigned 270, which is what we have now. Okay? Think about it from a population point of view. Take the same amount of address space, and I put it on just a few counties where most of the population is. The remainder, I give a whole area code's worth of numbers. Great, we're fine. So from 1947 to 1955, we were great with 1. 2 carried us for 35 years. Then we made a huge change like this, and the same year, we split off another area code that was Lexington and Cincinnati. Now, to be fair, part of Cincinnati's kind of weird because even though it's northern Kentucky, you know, Cincinnati Airport is in Kentucky. So there's some weirdness that goes on up there. But by population, this is all the 859 area code. By the way, you know the old movie thing of Plaza 3? You know, 4369, Pennsylvania 65000 if you're a jazz fan. Those are the same thing we call. Plaza 3 is 753. Okay? Area codes used to be assigned for just the reasons I stated, where the population was. Now that we're in the computer age, it doesn't matter. It's just as easy. Anybody want to know what 859 can be interpreted as on the telephone keypad? UKY.
That's why they got a higher rhythm music.
The chairman of the PSC at the time was a hardcore UK fan. No, I don't think it's coincidence. Our new area code, 364, depending on how you interpret it, is either fog or dog. Obviously, we don't have the pull. So I checked in. I literally checked into getting a petition started to see if we could get MSU. It's already been assigned. So the ladder that I described, where what's happening now, this is 270. They talked about doing another split, and there are all sorts of discussions about how you do splits. Do you leave the larger population area with the existing area code, or do you give the area with the fastest growth the new area code? You know, there are all sorts of things you can play like that. They initially, when they were going to do 270, they initially were going to do it as an overlay on 502, so that you had to dial 10 digits. And your parents and grandparents, my parents and grandparents, just threw up their arms. You mean every call we make is going to be long distance? That's what was wired in. Okay. You had a large population that didn't use cell phones, that were used to 10 digits meaning long distance, and no amount of explaining would convince them. And so they did a split on that one. That was, what, 1999. Here we are just a little later. We're doing this. And now, what's happened in those last 15 years, how many of you have a wired phone? Okay, you do. I do. Sort of a wired phone. I have what looks like a wired phone that actually is IP from the carrier's interface out, but okay. How many of you pay a surcharge for long distance? How many of you, if you make a one area code exchange call to Los Angeles, pay extra for that call?
I use a calling card because I get a much better fee.
Okay. Anybody pay long distance on their cell calls in the United States? No, and that's what's driving this. My sort of wired phone is a flat rate. It's $10 a month, no long distance. Okay. This is the first time we've had this issue come up in our state, that we don't have that heavy predisposition against a 10-digit dial. Now, it's not hugely popular. You know, nobody wants to dial a third again as many digits. But it's not that huge outcry. So we're going to do an overlay. What that means is that you have to, I'm sorry?
It's easier than splitting?
It is less disruptive. Everybody's existing number stays the same. Now, the downside of it is, you have a new neighbor, you have neighbors on your east and west. You get a new neighbor on your east. Their new phone number is going to have 364 as the area code. A few months later, and you have to dial 364 exchange code, 364-753-5549. My number's 5549. So I'm 270-5549, 270-753-5549. My neighbor will get 364, potentially, not likely, but potentially 364-753-5549. I get a new neighbor on the east. Potentially could get 364, another exchange, 5549. So it can get real confusing for people. Plus you're having to dial 10 digits. Now, one other reason, cell phones, which is what we all use, have always used 10-digit dialing. You didn't have to put it in because your carrier pre-pinned the area code as soon as you sent the call to them, and they have always routed on 10 digits. So we've been doing 10-digit dialing for a long time. You just haven't had to be the one providing the 10 digits.
The service I've got, I do that on 10 digits.
Do you?
Cell phone.
Okay.
I think that's because they lease
Yeah.
the set on their own.
Yeah. But the upshot of all this is you're going to see mandatory 10-digit dialing pretty much everywhere. Los Angeles doesn't understand why anybody thinks this is a big deal. They've done 10-digit dialing since the 80s in Los Angeles. We're just having to deal with it now, being a less populous state. Okay, so we've talked about the whys, wherefores, all that stuff. Who keeps track of all this stuff? Do you just assign a number? No, there's actually a North American Numbering Plan Administration. There had to be an administration, anything connected with the government. This is actually run under contract by Newstar. They run the database. They make the assignments. Go to this over the weekend. It's just do Google North American Numbering Plan Administration. You'll come up with it. It's www.nanpa.com. .org, if you mess up, is some wildlife organization. I don't even know what it is. Go in there and look at Kentucky, and what you'll see is all the decision-making and discussion behind this thing we just went through with this new area code, and you'll kind of see what's going on with it. Where is this going over the next 10 years? This is tied very tightly to the existence of the PSTN, because this ultimately is the public numbering plan. This is public address space fundamentally. As we move towards voice over IP, my prediction, my forecast, if you will, is that sooner or later people, and by that I mean your generation and the people coming up behind you, are going to say, why are we stuck with this 10-digit number thing? Why don't we just use, John.Hart or jhart@murraystate.edu? Why not? That is unique, right? That's my email address. It's registered. If you send an email to that from anywhere in the world, it will get to me. So why don't we use that for my work phone number? There's absolutely no reason we can't. In fact, our phone system is perfectly capable of doing it. The ones in our lab are perfectly capable of doing it. It's not a technology issue. It's a people issue. We don't want to do that. Telephones are area code, exchange, and 4 digits. That's what we do. And that's what we got to get past. You guys are going to be the ones dealing with this.
You think they'll just put it in the background and no one will see it for a year?
No, there's no reason to. We're doing that now. What we're using, what you'll find, this whole idea, the reason I made such a huge deal of identity, when you go in and look at what we're going to be doing in the lab, the first thing you're going to do is not connect a phone or identify a number. You're going to build a user account. You've used them. It's a network account. Okay? I can associate that account with anything I want. For you logging on Murray State's network, you have a username. You have a password. The system associates that username and password to identify you, because what you're saying is, hi, I am John Hart, and Active Directory says, prove it. Tell me what your password is, because only John Hart should know that password. You give me back the right you give AD back the right password, and says, oh, well, I guess you are. It lets you on. That's an identity that is associated with something only I know. And once I prove that I, the person, know that thing, that account is now associated with me, and it becomes my identity for the purposes of that network. We can do the identical thing with telephones. What do we do now? We do that identical thing in voice over IP systems with a telephone. It's just we use a phone number for the username. You had a question?
Do you think we'll get away from that?
Yeah, I think so. like I said, it's not a technology issue at all. And right now, the phone number thing services us well enough. What's going to happen, there's a concept called converged networking. It's been pretty badly maligned over the last 10 years, but basically what it means is you have a general purpose network that, from a network delivery point of view, really doesn't care whether it's voice, video, data, telemetry, what have you. You know, it's just stuff. We're going to move across the network. As that concept gets more and more and more rolled into what we do and how we do it, then the reason for having my voice account use a phone number and my email account use a username and my Active Directory account use a different username, we're fortunate here that our usernames are the same. And what's pushing it are these kind of devices. This isn't per se me. You ever tried to share an iPad or an Android or something like that with somebody? How many things on your iPad or your iPhone or your Android are uniquely associated with a username and password you set up, and that if somebody else tries to use it, they have to log you off and log their account on? You know. So even though that's not specifically me, to get the most use out of this, everything I do with this should refer to me. That identity should be associated with me, the individual. And that's where I'm going with that. Okay? Now, this is the one the university bought for me. It's, you can tell it's had an interesting life. Danny actually said he'd get me a new one, but I like this one. I can tell where it is on the table. My wife and I were traveling with it enough, and it was so handy, we bought a Mini that fit in the coat pocket for traveling. Great. You know, I'm old enough. I do these. I can use an iPhone. I don't know how. I can't see it. Or at least not well enough for it to be stress-free in a trip. So I tend to use the Mini for things like looking at maps or looking up where a museum is or a restaurant or something like that. Okay. So my wife and I shared that iPad for a while. Okay, well, it's got my Apple Talk account. And it actually worked okay because she was using my, messaging and all that. It's us and our sons and some friends and stuff like that. Then she started getting stuff that she was doing on her own. You ever tried sharing the computer with somebody? I love my wife dearly. She's wonderful. The one thing we don't do well is share a computer. It's really terrible. So we've ended up with two of those. Now, this isn't the big expose into how John uses a computer. My point is, the usefulness of that device is tied to my unique identity, which in turn, because of usernames and passwords that I store in this, ties this device to my identity, which is an awful long way around the world. But as we get to the point where this is how we do things, okay, you use an iPhone. It has your phone number. You can download music from iTunes. I'm using Apple just because it's everything. I can have fun with it. Same, Android does the same thing. You can download your music. You have an iTunes account, password. You have credit cards associated with that so that when you buy music, it's directly charged to your account. You have email, maybe emails on that system. All of those are different accounts, but that device then becomes the electronic version of you in all those different networks. Once that's happened, why do I need different identities? And that's what's driving that question. So, if we get to the point where that converged network is, the only thing that differs is exactly what mix of stuff you as an individual want. I don't really need the different identities. Now, the problem is nobody wants to share Active Directory. I have an Active Directory account here, jhart@murraystate.edu. Every one of you does. Morehead State is not, even though it's perfectly possible, Morehead State is not going to accept our credentials. Why? Because they don't want to. It's too much work. Security risk. It's perfectly possible, just not being done. And it's those kind of things that are driving this. As that gets more and more common, you're going to see more and more drive away from addresses that just don't make sense. Okay? So, I'll give you a break over the weekend. Honestly, I've got to catch up on some stuff. That's why you haven't seen exercise 2-2. At this point, 2-2 is going to go away. I'll roll in those questions with some other stuff and deal with it. I've got to move on. I am going to put up an exercise for you to practice these number patterns. We're going to spend most of next week, we're going to spend all of next week talking about and practicing how you build dial plans and how they work and how those routing decisions are made. We will start lab next week, so your days of short class on Friday are at least curtailed. I'm not limiting myself to 2 hours, but my lectures are mostly an hour. When we get in lab, the general form of what we're going to do is I will show you a complete working system that does the things I want you to see. And you will see it as a working system. Typically, that's what we'll go through on Friday. I'll have a lab that leads you through it. Look at this, look at this, look at this. Here's how it relates to what we've been talking about. And here's where we step off into the air with no bridge that we've ever seen before under. We're doing things differently. We're doing labs online. I'm rewriting this class completely so it can be delivered online. You guys using the lab effectively are going to be online. You're going to get into the system identically to how people out in the world do. It's just you're going to be sitting right next door to the equipment. Okay. What I will do after we go through that overview system is we're going to give you a series of short, detailed, call them detailed lab procedures. So if everything you need to do to make a working system is create a user, build a phone config, edit the dial plan, make routing rules, yada, 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 then I'll show you that whole thing, show you where stuff is, and then your first lab will be make a user, make 3 user accounts. Second one will be associate an IP SIP phone with one of those accounts, so on and so forth. Now, those are going to be done mostly as homework. I'll show you the system next time. Basically, you schedule. There are 4 lab stations. You will schedule one of them. We'll allow blocks of 2 hours of time. You may sign up for multiple blocks of time. You may not sign up for multiple blocks of time in a row. So you have only 2 hours. I'm designing them so that, in my opinion, you should be way under that to complete, but you have the 2 hours if you need it. Okay? We'll go through that in detail next week, but that's kind of where we're heading this week. Have a good weekend. Be safe.